In part 3 of Microprocessor Facts, we are going to talk about clocks. Every computer has a time of day clock in the lower right-hand corner. This clock is synchronized to a time standard by connecting over the network to a server that is linked to the National Institutes of Science and Technology. Time signals are also broadcast over the air, and you can buy standalone clocks with built-in receivers that lock to this time standard. But the clock we are interested in with regard to microprocessors is different. In previous podcasts, we examined the fact that a microprocessor is made from gates, and gates are made from transistors. We counted and added numbers in binary. So how does a bunch of gates actually execute the process of counting? This is where the system clock becomes an essential component of processor operation. I have built a counter circuit board to illustrate the operation of how a system clock functions. This circuit is composed of a Johnson decade counter IC, which is fabricated from 250 transistors on the chip. I designed LED driver circuits which are composed of 11 transistors, 22 resistors, and 11 LEDs. There are also 2 capacitors, a reset switch, and associated resistor on the circuit board. The IC includes decoding, which outputs the count as 0 to 9, and a carry output. The circuit is powered from a 5-volt supply, and the clock signal is generated by a pulse generator in the design lab. The system clock is a repetitive pulse that changes from a logic low level to a logic high level and back to low at a predetermined rate. For this demonstration, we can run the clock generator at a very slow rate, which allows us to visually see the LEDs illuminate as the count advances on the rising edge of the clock signal. The green LEDs are numbered 0 to 9, and the red LED is the carry output, which can be connected to another counter to expand the count. This counter IC is capable of counting with a clock frequency of 5 million cycles per second, so we could count from 0 to almost 455,000 in a single second. Propagation delays are specified at 500 nanoseconds from clock input to decode output. I used binary coded decimal counters to design the frequency counter in the pulse generator. Binary coded decimal counters output 4 binary bits for each digit to decoders, which then drive 7-segment LED displays. The clock signal in this instance is applied to the counters for exactly 1 second, and the accumulated count is displayed. This is the frequency output by the function generator in cycles per second. In a microprocessor, the system clock does more than counting. It also enables data to move from one section to another, to load data into specific memory locations, to execute instructions, to interact with peripheral devices like printers, scanners, audio devices, etc.